Right. So we talk a lot about vector search as the key capabilities in this platform. Lots of search engines have vector search, but they are not created equal. To enable efficient searching at these scales, we employ Sharded disaNN vector search, originally developed by Microsoft Research and now by right into Azure Cosmos DB. So disaNN is a graph-based approximate nearest neighbor algorithm designed for massive datasets. It combines the graph building algorithm with product quantization to compress vectors, so it can search billions of data points efficiently. The key innovation is that it stores most of the index on fast SSDs while keeping the compressed pointers in the RAM for quick access. So this combination gives us the high accuracy and low latency and the ability to scale far beyond what in-memory approaches can handle. So now with Sharded disaNN built into Cosmos DB, we take that performance even further with the large-scale multi-tenant scenario that Veeam is dealing with. When you set a vector index shard key in your container indexing policy, Cosmos DB automatically creates multiple disaNN indexes, one for each unique shard key value. So that delivers several key advantages. Number one is low latency. So each tenant index now is smaller. So search is complete up to 91% faster, according to research from Cosmos DB team. And it reduces cost because smaller indexes use less compute, cutting IU consumption by as much as 85%, and improve recall, right? So focusing on, because most of the time you just search, I mean, in Veeam's case, users only search within their own tenant data, right? So focusing on the right tenant data makes the result much more accurate with the recall gain up to 12%. And then better scalability, right? So when we need to add more tenants, it's just a horizontal scaling, so which is natively handled by Cosmos DB. And finally, the tenant isolation, right? So each tenant, they're gonna run on their own search index. So all of this empower Veeams to deliver low latency, cost-effective search on their massive dataset.
Thanks, James. We're going to deep dive on cost optimizations also because we need to make this financially viable, not just for Veeam, but for our customers. So we're going to go back to the original document schema that we talked about at the start of the presentation. Again, we have the metadata and we have the vector embedding. The vector embedding, when we broke this down, the document consists of basically 1 kilobyte of metadata and 6 kilobytes for the vector embedding. And when we did a cost analysis, we found this was not going to work for us because we have to pay for RUs to insert, we have to pay for the data that's stored at rest in Cosmos database, and then we have to pay for RUs to retrieve the data. So I'm not going to say you get hit for the size 3 times, but it's a consideration in 3 of the different places that we get billed. And so what we did is we worked with the Cosmos database research team, James, and we figured out how to reduce the size of the vector embedding down from 6 kilobytes to 1 kilobyte. And what we did is first of all, in the Azure OpenAI API, you can request a fewer amount of dimensions. So instead of 1,536 dimensions, you can request 1,024. And then we also quantized the dimensions themselves from float 32s into int 8s. And so altogether, if my math is correct, this comes down to 1 kilobyte, and it effectively reduces our cost by over 5x for Cosmos database.